control. And under section control, we have here the natural section control, such which also shown in figures and photos, represented by sand, gravel, stones, and rocks. And the other section control is the artificial control. Section control represented and showed the man-made, such as plumes, weirs, and etc. And also, Sir Michael enumerated the ideal characteristics of section controls from ratings. Ganun din, nag-present din si Sir Michael ng slides regarding that. And the duration of the discussion, we learned also how to determine offset in relation to the effective PCF or the point of zero flow. So here explains the relevance of offset in our data gathering. As we all know that when we are gathering or developing a rating curve and conducting a rating curve observation, or let's say flow measurement observation, we often nababanggit yung offset. So here discuss what's the relevance of the we call offset. We discussed in lesson 6 the difference between the sensitive and insensitive control in rating curves in terms of rating shapes. Then last, at the end of the lesson, we learned to extrapolate rating curves. We also learn how to rate and grade whether the derived data are poor or good enough. Then nagkaroon tayo ng morning break, and after the morning break, we started the lesson 7, which is the threshold and open-ended correction. Here explains how we correct or eliminate some data that are not necessary in our development of rating curve. We also learn how to determine necessary correction to apply for a specific data, such as adjustment, trim, offset, override, outlier, trim, and many more. So after we identified the correction type to be applied, we also try to add correct data. Nagkaroon tayo ng pag-add ng data, also yung paglagay ng notes and grades in our develop rating curve. So last, before we dismiss, nagkaroon tayo ng question and answers, and that's all, ma'am. Thank you.
Thank you, sir. So now naman po, now that we've settled down and had our recap, since our speaker is already here, I think we can continue on the discussion. Good morning, Engineer Michael Bard.
Good morning, everybody. Welcome to day 4 on Friday. Look forward to finishing off these sessions with you. Shall I carry on?
Yes, sir.
Let me know when you can just see my screen. Just confirm that everybody can see that.
Yes, we can see it now.
Okay, so thank you for that summary of where we got to yesterday. It was a very good one. So what we have been doing is working through filling in data and doing corrections based on this model here. And I was just looking at it before, and we are pretty complete, but there was one area in it that while we've done it, we haven't really looked at what it achieved in terms of looking at the data sets. And that's on day 1, we talked about datums, and we created this derived data set, this vertical datum, but we've never really had a look at it. So I thought we'd just very briefly just have a look at that data and just recap what it does and why. So if we go back, we can see we have this vertical datum, and it's now got data in it which it didn't have when we created it. So let's have a look at it. I suggest we know that it was created from the working data set. So let's click both of those and then open them in the data review tool. And the first thing you notice is, it's hard to see much because you can't really see the detail of them because they're all on the same scale. So the one thing we can do here is, and this is really just to show you partly how the tool can be used, is when we look at the vertical datum one, we have some options and we can say to show it on its own axis. So at the moment, we're showing both data sets on the same record, which means you don't see much detail. So let's click on that. And then we look at that and kind of go, well, where's the vertical datum gone? And really what has happened is, if we look at it, because the way the auto scaling has occurred in terms of the stage dot working is showing from 2 meters to 5 meters, and we've used almost the same scale on the other y-axis of 272 to 275. Basically, the two records are tracking exactly over the top of each other, and therefore you can't really see one of them. So if one option to just prove that is, instead of using auto axis on this one, let's use a fixed axis, and we'll just offset it a little bit just to I guess demonstrate what it does. So if you see, now we've got a little bit of a difference in the scales, and so we can see the two. And what we can really see is that these two data sets basically track each other with 271 meters difference. And we kind of go, well, that makes sense, I think, but why did it do that? So let's just recap what we said and why it adds 271 meters to convert the stage dot working to the stage dot vertical datum. If we look at the rule on the vertical datum, when we created it, we set it up where we said it's a reference datum conversion, so that's the type. And then the inputs, we said the input was the working, which we know, and then we said it was a local assumed datum, and we wanted it to be this NAVD 88 datum. So that sort of makes sense, but how do we know the NAVD 88 datum needs to be 271 meters? If we also remember, when we set up the location, so if we look at our location and go to the location details tab, and remember back, we set up something about the reference datum under the location. And what we said is that we wanted NAV to be available as the base reference. And not only that, we set up a rule that said for the entire record of this location's local datum has been 270 meters above the NAVD 88 datum. So that bit here is why when we see the two records, they're 270 meters apart. And if that changed over time, we could have added different records with different periods, because we do know, or at least, in many places, the actual levels of things with earthquakes and general tectonic plate movement, things move a bit, and depending on your purpose, that may be really important to be tracking that. And this is the method. So the method will allow for you to change that over time. You might find that, as we did in Christchurch here in 2011, after our earthquakes, most of our locations had moved a little bit and we had to readjust. So I just wanted to just quickly review that, just because I guess we had set that up and we just never really looked at it. And just to show you that we can set up these values and publish them, with an offset to a datum. The cool thing about this now is that what we are publishing in the vertical datum is adding 270 meters, but all the corrections that we make to the stage dot working have been reflected in the result of the datum. So as we change things in the stage dot working, the vertical datum will be being recalculated. That's what Aquarius guarantees through these things. When something is derived from another one, if the base thing changes, then the derived one is re-updated. So that's one of the core underpinning items in Aquarius. Okay, so I just wanted to quickly review that. Coming back to today. So yesterday, as was covered in the introduction, we went over a first look at ratings and we did thresholds. If we look at the normal course outline, which I'll just blow up a bit, normally there is a lesson 8. We have chosen not to do lesson 8 in this particular set of workshops. Now, there's a couple of reasons for that. One was because we had constrained this down to 2 days, and the actual work, the full course, particularly when people are around, is more like when we're all together physically, is a 3 to 4 day course. We needed to take some content out to get it to fit. The other point was, of our experience, we've often found that lesson 8 can often be difficult to understand for people as part of this course. What we find is that lesson 6 is a good introduction to ratings for people, and really the benefit for people trying to use the tool of ratings is to have some time practicing at that sort of level of this lesson 6, making sure they're familiar with that before they kind of come on and look at the more complex examples of ratings. So that's why we have left it out. The good news is, for anybody that is interested in ratings, and I'm sure a few of you out there are going to be responsible for ratings, lesson 8, all the material that we supplied, I believe anyway, has included the videos done by Aquatic Informatics, and lesson 8 is present as a video. So in your own time, when you're ready, you can review lesson 8. So for those who are going to get into ratings, I would suggest you go back and do lesson 6 on the test system and experiment and just understand those, and then move on and watch lesson 8 and try that exercise yourself. So what we are going to do today is very quickly 3 sessions. So first lesson we're going to do is lesson 9. So we're going to do some calculated derived time series. Now, the person that asked me yesterday about, can I have 2 ratings with sort of different rules in them, in terms of, in a certain range I use one, and in a different range I use another. I believe the exercise here today, or will show you a way that this can potentially be done. Well, a couple of ways it could potentially be done. Either directly through a rule, or by a rule that references a couple of derived data sets. So for the person that asked that question, listen to this, and then if you've got any follow-up questions, please type them in, or just talk to me when we do it. Once we've done these calculated derives, we move into the last couple of sections, which, if I rotate this clockwise, comes into data review and approval. This is mainly about approval, which we haven't talked about at all up till now. Approvals are about workflow, indicating the workflow of your data. And we'll talk about that when we get to it. And then the final section that we have a look at is reporting and exporting of data. So that's looking at the available reports. Okay. Are there any questions before we start? If not, we'll get straight into section 9. I've got to turn my diagram back around again now. So lesson 9, which is page 108. I realize today that I've been calling out page numbers based on what I've been seeing up here at the top, but I actually see in the printed version we've actually been 1 page number ahead. So I apologize if people have been following through and looking at the page numbers of a printed copy. That I've been about a page out when I've been reading it, but I've been reading it based on what I see when I look at it online. So hopefully most of you have been looking at it online and it has made sense. But for those that may have been confused, I apologize. So as I read it out, page 108, lesson 9. So we're going to get involved. The derivations that we've done so far in types have been statistical ones. So we've done dailies and we've done means. But now we're actually going to do some examples where we express some logic in a scripting type language to get it to make some decisions about how we derive the data. So the example we use is a pressure transducer and a barometric pressure. I'm not, if for those that don't know, often in the pressure transducers measure the levels in a certain way and they're affected by the atmospheric pressure. And so to be more accurate, what some of them require is you to adjust the level that's been output based on the barometric pressure in the time. So this example is working through an example where we're basically trying to adjust a record based on a barometric pressure record. So we will start with step 1. So step 1 is a case of we're actually going to create a couple of new data series to do that. So this is kind of going back to what we did on day 1. So we're going to create a new, so under our location, new derived time series. Because it's derived, we need to set up the processing period for it. We're saying it's a pass-through. I'm just having a look, and we set the process inputs to. Now that could be interesting. I might have to quickly create that. The complete, is that location in here? Okay, I'm going to have to create those. So we'll go through an example. Let me just find those records. So I will load it in and then we will reference it. So we need to create this first. So we will create a basic time series first. Stage. Meters. So I have created a new level logger and I'm going to load some data into it. There must be quite a lot of points in this. It's taking a wee while to load it. So if you're looking at the manual, what they have done in the manual is they have already loaded these data sets into a couple of examples locations, and in their example, they're actually just passing it through from a different location into this location. But on this test system, that location doesn't exist, so I'm actually loading the data in directly from the file. And I think the reason they normally preload it is because it takes quite a long time to load. So while I'm waiting on that, oh, there we go. So we will now append it to our stage.level logger. And we'll append it. And then I'm going to do the same thing with the barometric pressure, where again, the notes have us passing it through, but we haven't got that location, so we actually need to load it directly. So we'll close that. So we now have a stage.level logger with data in it. Oh, there. So we just refresh it and we can see the data. There's the data. So we're going to create the other one. So it's new because we're loading data into it. It's a basic time series. This one is different. We haven't done this one before. It's atmospheric pressure. So if we start typing, oh, sorry, that's not the label. The label is baro logger. The parameter type is atmospheric pressure. Units, KPA, we're happy, instantaneous values. So we've created that. Now we load data into it. And they've given us the config file to go with it. We load the file. It's probably going to take a similar amount of time. So this is just reviewing, I guess, what we learned on day one. So when you use these tools for a while, you can get quite proficient at setting up these new locations reasonably quickly. There are other alternatives for setting up locations using the API. So just while we're waiting for that to work, just a quick reference to, for those people that know what we're talking about, there is application programming interfaces in the system. So this is for people that might want to write computer programs or Power BI or these sort of apps that we might want to use to read data from Aquarius or provision it. There are 3 application programming interfaces available to do this sort of thing. So provisioning is an interface that's used by programmers who might want to configure the system through programming rather than doing it manually. We saw the system config pages that can set it up, but you can do it programmally. Acquisition is really about loading data. So if you had a telemetry system that you wanted to load data into Aquarius, you might well use this acquisition API to do that. And then the third one is publish. So that's about reading data from Aquarius. So most of any reporting processes or anything you create are likely to use the publish API. Okay, so that data is loaded. Let's append it. We need to lend it to the atmospheric baro logger. And if we get a little bit of time at the end of today, I might quickly just show you a little bit of the user interface that can come with this as well to practice with. So appended. So there we've got our data. And if we now look at it, we can open those time series. So if we look at the stage and the atmospheric pressure, we can see the record is changing. Again, trying to remember how things work. You can see in this view at the moment, there's no points. So just reminding you, if you like to see the actual points as round circles, you can see them in to give you some idea of the actual points in the system. So you can turn these sort of features on and off. So what we're going to do now is, the theory is that our level record actually needs to be adjusted based on the way this barometric pressure goes up and down. And there's a formula that says how that should happen, and we're going to set that up to create a derived time series that is adjusted based on this atmospheric pressure. So for those that are following along, this is now step 3. So what we want to do, we just unclick that for clarity. With our location, we're going to create a new derived time series. Like most others, the first thing we do is set the processing period. The difference is in this time, and we are going to pick calculation. So we haven't done a calculation before. When we do a calculation, there are basically inputs, because these are the things that we want to reference as part of the rule we're going to write. So generally what we're talking about is these are references to time series that we want to reference in the rule. So to be able to reference them, we end up writing the rule down here in the formula. But before we write them in the formula, we set up the time series that we want to reference. So in this case, the example is we want to reference the level logger, and we can add another one by going add calculation, and the barometric pressure. Couple of things to immediately note, and we will try them later, are these buttons over here. What the tool is going to do is, because it's a derived one, it's going to basically say, I need to follow this rule, but which timestamps do I use to follow the rule with, in terms of, what timestamps should I have on my outputs? What you have to define is one of the input time series says which data points there will be an equivalent output data point for, i.e. every timestamp in the one you select, there will be an output timestamp in the output. And you mark which of your time series you want to set as basically determining the timestamps through setting the master. So only one of your inputs can have the star set. Generally, by default, it's the first one. So what that means is, in our output, there will be a timestamp value output in this time series we're creating for every timestamp there is in this data set. Does that make sense? We can obviously delete it if we're not going to use it. The third item, which we will come to in the next exercise, is we can actually time lag the data. So you can move it an hour, you can use a value an hour earlier or an hour later. Well, not later because it wouldn't be there, I guess. But, you can certainly move the data in time as part of your rule. So again, if you've got a upstream site and a downstream site, you might want to set a formula that's based on it. But because there's a propagation time, you might want to use a value in the upstream site that is or this site 30 minutes, it's a 30-minute propagation time. So you might adjust the time values for some of your lookups by 30 minutes. So that is possible in here. Not in this exercise, we don't need it, but the next one we will do. We're not worried about setting the measurement. So the power of what we do in the formula gets set here. And in the example, they've asked us to put this in. So it's just a basic mathematics formula. Whoops, and I've missed a bit of it. So the general form of the formulas is y equals, and you can reference the identifiers. So these identifiers are what you can reference in your formula, and then you can use various mathematics and logic, and we'll do a bit of logic shortly, to set up the formula. To check that your formula is syntactically correct, you can hit the validate button. And you can see immediately in our first go at this example, it's saying you're not syntactically valid. There's something wrong with your formula, and it gives you the hint that it's x1x does not exist. And if we look, our first identifier is x1, not x1x. So we need to delete the x on the end of it. And then if we validate, it should say we're okay. So then we can hit OK. Then we need to say, all right, we've set up the rule, we've got the data, what are we doing with the data? And the question is now, where are we putting the result? And so we create a new time series, the label compensated, and we might put a description in because it can be useful to help others who are looking at the stuff to know what all these related and derived data series are and why they're there. And then we hit save changes. And then we see this is turned up in our list, and you can see calculated ones have this icon in the list. And we can then open it up, and maybe when they want us to open up and have a look at it, just seeing which time series they actually want us to look at. So they've suggested we look at all three. So stage.working, where did we go? Atmospheric pressure.barologer, and the one we just created. And let's open them all in the time series. Now, what you can note from this is because we had two different parameter types, so two of our items are stage, it stuck them on the same axis, but because our atmospheric pressure is a different unit, it did automatically put it on a separate scale. So if we can't quite see that stage.compensated at the moment, so let's just check that it's there. So we can turn off the others. Turn that one off. So we're not seeing much there at the moment. So let's have a look and see if we can see why. So has it calculated it yet? Let's just check the system's had time to calculate it. So now we can see it. So maybe we just try and check that again. So I think we need to use our thinking caps here and look at why it might not be showing. And let's have a look at the dates of this data set. So you're probably sitting there saying I've been being silly, and I have been. The input to this data set is not stage.working. We don't actually want to see that one because it was stage.level-logger. So what we were doing is because we'd opened stage.working and I'd chosen to use that one, we were looking at data from 2013 to 2015. And this data that we'd actually loaded is 2012 to 2013. So I think you'll find if we look at it now, this will probably make more sense. Here we go. And we can clear them out and see them if we want to. So let's just So there's the compensated and there's the uncompensated. You can't really see the difference, but if we zoom in, hopefully we will see more accurately. And it's only a little bit different, but when you look at the formula we put in, the barometric pressure adjustment is only a tiny little adjustment. So that makes sense that what we're seeing is that the compensated value is not greatly different from the original value. So we can turn these back on so we can see the various records. So that's the first example of how you can use scripting syntax in the formulas to create a derived time series. Now we're up to stage 5, and this is where we'll do a slightly more advanced one, which again, this is where I think we were talking yesterday about the potentially needing to reference different data sets. This is, I guess, the if logic is useful to you. So you could put, if you think of, say, X1 was a level record, you could say if the level is less than this, give me the value from rating 1, basically, and if it's otherwise, give me the answer from rating 2. So you can express this logic. If I wasn't quite sure yesterday, if the formula you were looking for the rating curve was just a straight mathematical formula, then potentially you didn't need a rating at all, and you could just put the formula in here directly without needing to create a rating at all, potentially. Or, you could do a mathematical formula off the stage, just a different mathematical formula on the stage values. So that's what I was thinking in terms of achieving this based on the question yesterday. But let's try and do this one. So what they want us to do in this exercise is change the formula. So because we're not keeping it, they've basically just said, let's change the formula in the existing derived time series that we've done. So where we did the formula here, it shows you how we can edit these. So this is our calculated one, and we want to change the rule in this example. So let's go back to the rule. We know it's in the processing period where we wrote the rule. We got the processing inputs. And if you're following along, they have said you can copy the formula, and there's something from here. Just I think if you copy and paste it from the manual, it puts a few funny characters in it, so they tend to supply it in here. And one of the things you can do with these UIs is this bit here, you can drag it so you can see a little bit more. If you drag this bit, we can see the formula. And so if we look at what this formula is saying, it says if X1, which is our logger level, is less than 9.8, then the output is going to be the square root of this formula, which is based on a difference between the two data sets. Otherwise, we just pass through the original one. Sorry, if it's between 9.8 and 10, we just pass through the original record. And if it's, what's that, above 10, it's just going to put out the output as 9. So you could think in my example, if we added another one here, and this was basically rating 2, so this is stage rating 2, rating 1, you could say if X is less than 9.8, Y equals X2, say, if this was rating 1, else Y equals X3, which might have been rating 2. So that's one way you could do it if you were deriving the outputs with 2 ratings, or as I said, potentially, you can do most mathematical functions in these formulas. So if this relationship is actually a mathematical function, you could just do it directly in these equations if you chose to. So good practice to validate this and make sure it's okay. It says it's all right. Something to note is there you can get more information about this by clicking on this link. So that takes you to the help, which gives you more details on exactly what mathematical functions and time and how to do time lags and what you can do. So if you want to get more detail on what you can actually do in these formulas, then click on that link and go to the help. So that's just that link that sits up there. Or you can just search in your help generally for it, but that one will take you directly where you want to go. So we go OK. Oops, and it's not like now. So here's a good example. I added in that X3 because I was talking, but I didn't actually reference it or fully syntax it properly. So it hasn't let me save here. So I just need to delete that before I hit OK. And then we go save. And then this time if I pick the correct input, the stage.level logger, that one, and the barometric pressure, and have a look at all three of them again. You can see, and maybe we'll just look at the one we created. Before it was mimicking that arm with very little change, and now we can see we're getting some values that are 9. And that was, if you look at the formula, where's our formula going? Up here. If the value was basically greater than 10, it was said if the input was greater than 10, it was going to make the output 9. And so what we would probably find if we zoom in on some of these sections, the inputs are, as you can see, above 10, and that's why the output goes to 9. So it's following that formula that we put in. Okay. So hopefully that helps in terms of how you potentially could do that example we were talking about yesterday. The next example we want to do is one I did talk about, that you can do time shifting of these derived ones. And so this step 6 is just an example of doing a time shifted example through calculating rate of change. So if you want a data set that's going to be useful to you to do rate of change, I think this one's rate of change, is it? Oh no, sorry, I'm getting ahead of myself. Rate of change comes later. This one is just a straight temporal one. Am I really getting ahead of myself? Sorry. I'm getting ahead of myself. This one is a temporal example because we've got 2 different processing periods. So this is saying we're going to have one rule. This is not one where they're going to move the time and move the calculation of the data set in time. It is from this date to this date, this rule should be used. From this date to this date, a different rule should be used. So it is a temporal one, but not quite what I was talking about. So let's do this one. Step 6. Page 112. So what we're doing is we're going to take the example we had, and if we want to change the rule on these ones, is we need to add a new processing period, because we're saying from this date on we're going to use a different rule. And so they've told us to use the date 2013-01-01 from the time 07-45. And the processing type is a calculation again. We're still going to use the same 2 inputs, so we need to put them back in. So this one is our level logger again. So we're using the same items for the rule, but we're using a slight variant of the rule. So in this case, They're saying that should be the rule. What we will also do is, so we just validate that, make sure it's good. Is just to be clear, we will take this formula, which is the original processing period, and just put it back to its original formula. Which was this one. So we just again validate that. It's okay. So if we just quickly look at that, we are saying from the beginning of the record until 2013 on the 1st of January, we use this record, this rule, which is this adjustment. And then at the moment, I think what we're seeing is this one has the same formula. Was the other one plus? Was it plus or minus? So they're the same formula at the moment. I put this, so. So what they actually wanted us to do is this. Let's get through this again. On the first processing period, they wanted us to use this formula. And then they wanted us to add a third processing period. So we can have as many processing periods as we like. And this one, they said 013, 04, 03, 0000. Processing type calculation. Get our inputs in again. Oh. Another one. And then for that last period, they want us to go back to this formula again. So we have 3 processing periods in this example now. And basically, let's have a look at what it does. So we will just check that it's recalculated. So if we look at the processing time, we want to just check that we see the updated time is something like our clock, so we know that it has done the update. And if we now look at this record, we can see we've got negative numbers because if we look at the formula, the first period is negative and the last period is this negative formula, which is what we're seeing up to there. And then so from these processing dates, those ones are negative till the second rule. So this is the period of the first processing period. This is the period of the second processing period rule. And this is the third processing period rule. So I think we've looked at that. This next example is the one where we do the rate of change that I was talking about based on time. So this is the one that I was talking about before that we're now going to create. And this one we're going to take another step because it's a rate of change, they're actually going to link it through right through to our rating tool to be able to give you some idea of when you're looking at the gaugings, you can see effectively whether the record around the time of the gauging was increasing or decreasing. So i.e. was it on the leading edge or the recession of the event, if you were in an event when you were gauging. So an idea of change. So for those that are following along in the manual, we're up to step 7, page 114. So we're going to create a new derived time series. I'm going to set the processing period up. It's a calculation like our last couple of examples. We need to set the inputs up. So in this case, we are just going to have one by the look of it, stage.telemetry. And then what we're going to do is we're going to add another input, and it's going to be stage.telemetry again. Does anybody know why when I seem to hit the dot, everything disappears? I think it's because this is actually a case sensitive type. So you tend to get that far and then do it. So stage.telemetry again. We can see that this first line is the primary, but this one we want to lag on time. So to do that, we click on this adjust time icon and we change it to -1 hour. So what that is saying is X1 will have the value for a timestamp. X2 will have the value for stage.telemetry at a timestamp 1 hour earlier than the timestamp of the X1 variable. And if you think of the formula that we then put in for that, which is y equals X2 minus X1, that is effectively going to be the amount of change in the last hour. So this formula becomes, the rate of change in an hour. So having set what the rule is, let's just validate it and make sure we got it right. We go OK. Where are we putting this? We're putting it in rate of change 4. And the note that they've asked us to put in. So they also want us to do this. So we're going to create another one based, that one we did it off the telemetry. They're suggesting we also do it off the working. So we'll also create that one. So it's a new derived time series, processing period, calculation, inputs. So the change for this one is they want us to use the stage.working, but do the same thing. So add it twice. Put the hour offset in it. Put the formula in. And then put it in. And then we're going to put that one in the time series called rate of change corrected. And then if we give the system a chance to calculate those, so let's just wait till it does. Where are we with these rate of change? So they've calculated. And so we can see the rate of change. Now that doesn't. So just rechecking what we did there. So if we want to look at the actual values, let's just pick on one of them and have a look at it. So the raw one we did on telemetry. So let's have a look at the stage.telemetry and look at them in comparison. So maybe we'll look at it in terms of so this is we're not really seeing it clearly because our stage.telemetry, I didn't do all the corrections on it, so we're not seeing the scaling. When we look at the stage.telemetry, we still have these scaling issues because we're looking at periods where there's not a lot of change. So what we could do, let's do this. If we zoom into a period, so let's look at this period here. You can see the rate of change. And even better, if we potentially put the rate of change on its own axis, you'll see that even more clearly. And if we put the data points on, so you see this is the telemetry feed, and we go back an hour. So let's just zoom in on about an hour. So if we look, there's an hour between there. So that value was 5.2 down to about 5.0. So about almost 5.1. So this value at that timestamp is about 0.1 or minus 0.1. So that's the example of a formula where the formula is based on taking the value an hour. So for this timestamp, this value here is this value minus the value an hour before it. So the 115 one. So that one minus that one, that one. Does that make sense? And if we look at it, we're saying a negative, where are we on the scale? The negative value is because we did X2, which was the hour before. So 1315 minus X1, which was the value now. So that's why it's negative for here, because if that would have been X2, that's X1, and it was X2 minus X1. Hopefully that makes sense. So what, if we keep moving on in the exercise, what that means is the record is showing the rate of change. So therefore, that can be interesting when you are looking at gaugings and in the rating, when you're preparing ratings. It's nice to know, or it could be useful to know, was this a time when the levels were going up when this was gauged, or when the levels were coming down? Because some sites have relationships that change, and we know certain effects happen during the recessions versus when it's when the event's going through. And so it can be useful to identify what was happening in the rating editor. And so what we're going to do now is we're going to show you how, if you calculated a rated change like that, that you can see elements of that in color code, in fact, the gaugings and the rating change to help communicate that. So this is step 8. So in step 8, we're going back to looking at the rating editor. So if we go back to our rating editor and we open it, in the field visit table, so this view down here, so we're looking at the field visit information, you can click on the gears and it gets options. Within that, if we look at the time series tab, we should be able to find the new data set that we created, which is the stage rate of change. And we can say, please show this in the field visit table, or at least the value. What that's going to say is, show me the value from that time series at the same time as the time of the field visit. So if we show you that, you click across there, and that will put it at the end of the list. They've said, just to make it simple for us to see it, move it to the 3rd position. So what I did there is I just grabbed it and dragged it with my mouse, for those that are following along. So you can drag these items, you can drag them to reorder them, grab them, drag them. So if we now apply that, what we will see is that we have the value from this new data set that we collected based on the timestamp of the field visit. So what it's done is it's found the timestamp here, and it's looked up this data set and found the value and put it in here. To give us an impression of whether things are in recession or not, they have suggested that we color code it. So the instructions in the example is, what we're going to do is any change that's above 0.1, we're going to mark it as red, make the gauging appear red. And between these values, green, and that one fuchsia. And then what we will see is we will get different color coding to give us idea of what was happening according to this in the hydrograph. So let's do that. So the way to do that is, the first thing, easiest way to do it is to order this field visit table based on the one we were talking about. So this is the one we now want to color code, and it's now in order. And it has said anything below, well, let's do it from top to bottom. Anything above 0.001. So that one is all the way to, what did I say? 0.01. So those two are above 0.01, and it said make them red. So the way you do that is you select them. So just to be clear how I did that, I click this one with my mouse. The one that I wanted to finish with, I held the shift button down and then clicked with my mouse again. That then gave me the range. There's only 2 in this case. Then to set the color, I click on the customize colors, and they've said make that one red. So we're going to go red. What you'll now see is those colors appear as red. And what it means is when those gaugings now appear in these diagrams, they are red. The next part of the rule is anything between 0.01 and negative 0.01 should be green. So in our ordered list, that's below. So that's our first one. So I select that. And these ones, that's the last one. So that's the next bit of the range. And they said again, mark those colors green. So I'm going to make that green. And then the ones that are below that, so that's our remaining ones. So if I click that again first with my mouse, the last one, shift, click, and then say the color on it, and they said fuchsia. Well, in fact, those are already fuchsia, but I'll do that. So what you now see, and you can see that we've done it in the, it relates to the height pretty much. We can see the color coding in our thing. And if we look at the time series and we just zoom in a bit on it, we can see the different conditions. So it wasn't much change happening when these ones were gauged. This one had a high rate of change and it was positive. And these ones had a negative one. So the falling edges tend to be negative. And sometimes that can be useful in validating. It's really, I mean, this was an example, but it can be useful in validating your expectations around gaugings and potentially whether you expect the gaugings to be to the left or the right of your rating, because you may know the way that site behaves, that gaugings done on the rising limb may fall to the right or the left, and the ones on your falling edge are often slightly to the left or the right. So you may know that at your site, and this can be a way of color coding to sort of give you further evidence that what you're producing in terms of your ratings makes sense. So this generic, you could do this with adding this time series to the field visit view. You could do this with any time series that you create that makes sense. So while we've done it from a rated change ones, if there are other time series that you create that are useful to you in this rating preparation view, then you could follow a similar process. That is all the lessons for derived ones. Were there any questions at this stage on derivations based on what we've said? Just see, no further questions immediately. If not, I think we're doing quite well in terms of time, in terms of we'll probably be through this material before the end of the day. So we will have another opportunity for questions at the end if people want to raise some. So lesson 12 is about, I would call it workflow. So it's about having a look at your data and approving. If your organization is like ours, at NIWA, we have a quarterly process for our hydrometric stations and an annual process. And what we do every quarter is we're collecting data in near real time, and often the data is not necessarily edited straight away, but what we do have is a quarterly process that ensures that any corrections that should be made are made at least quarterly, and that includes going to site and doing special staff gauge checks to provide this evidence to make sure we are happy that our real-time stage records actually were reflecting the truth. So what we do is we use approvals to reflect in the data how far through this process are we. So when data first comes in for us, it gets one approval, and then as we move through the process, we give it an approved process after that quarterly check, and that's done by different people. So approvals are effectively workflow. So let's just have a look at a couple of examples of the sort of workflows that you might have. If we look at, let's start with, in the training system, we have 3 approvals defined. There is working, which is what data starts with, and then there's in review and then approved. And so that would be typical of, your data would create it, and when someone's working on it, they move it to in review, and then they pass it on to someone else who checks it, and then it would be approved. That's kind of the workflow you've got. In Aquarius, there is a general, they have these different numbers, and generally, the numbers will tend to go up as you're working through your workflow. Some key items about them is any approval in Aquarius that is above 1,000 is considered a locking approval. And what a locking approval means is nobody can edit it. Doesn't matter what role you've got, all these sorts of things. If it is in a lock state, you cannot edit it in that state. You will have to move it down. You'll have to approve it down again before anybody will be able to edit it. So a locking state means nobody can edit it. The other thing about a locking state is Aquarius, what they do with this is not only is it a locking state, but if it's a formulaic type derived item, in the locking state, it actually stores the value based on that formula, not just the formula. And what they guarantee is if they do an upgrade and ever change some of their algorithms, the locked data in the locking state will not be recalculated. Until you unapprove it and rework it, it'll do it. So it guarantees that that value stays the same, even across software upgrades. If you go back and take it down to a lower level and re-edit it, then obviously it recalculates at that point. But while it's in that locking state, Aquarius will ensure that it does not change. So locking states are part of it. So in this case, in our example, the 1200 is the locking state. And that'll be interesting because when we go through the examples, they actually suggest the in review. We are asked to mark some stuff to in review, but it's not actually a locking state, and we'll see that. Just to show you the difference, this is the approvals we have at NIWA. They are pretty similar. We have, again, one final state, which is a locking state, which is our approved one. How our process works is data comes into NIWA and it starts life as provisional. Then our field teams in the quarterly process, if they're a big team, they will tend to have a person that works on it. And when they're finished, they mark the data as in team internal review. And what that's indicating is that the first person's checked it and now the second person needs to confirm that it's okay. So in a big team, it starts provisional. The first person does some checks on it and marks it as team internal approved. Then someone checks that work and it goes to team approved. Once that's done, the team is saying we're finished with the quarterly process on this data. In a small team, they tend to just go straight to the team approved because they're not big enough to have an internal check. What happens then is that this data is then checked by our central person, so the database custodian that sits in my team centrally here in Christchurch, and she checks that all our procedures have been followed and that the comments are there and that any gaps are appropriate or have been filled, and which these guys should have done. And if they have done all the work correctly, she then approves the data and it is locked. So that's how it goes. Our practical experience of approvals was they seemed really good and we were quite keen to put a lot of approvals in when we first saw this tool. What we have found out is all of these approvals take time. So you need to just put in the ones that really make a difference to your business, that you want to be able to see, okay, I understand this data's had been through this processing, this data's been through this processing, this data's been through this processing. Do the important ones that make a difference to your business. Because if you've got 500 sites, every time you require approval to change, it takes a bit of time. And while each individual approval doesn't take long, and you'll see some approvals will approve multiple data sets at the location at once, it still adds up. So in an operational efficiency sense, make sure the approvals you use are value adding to the organization. Don't get too excited about them and put lots and lots in, would be my advice. This is sort of, as you can see, that's the number we've settled on, and mainly we move between provision. We mainly move between these four. If some data gets set back for working historically, so if it's been approved and we need to rework it, we mark it back down to working. So we do use this many. Many places don't have too many approvals, I think. Another thing to think about when you're talking about approvals is how they work. So if we look at our example site that we've been working on, and this is not all the data sets, but if you think about it, most of what we've been doing is stage.working. Stage.working has two rules about how it gets its data. It gets its data from stage.logger and stage.telemetry based on dates. So until end of January 2014, it gets its data from here. After that date, it gets its data from here. That's how stage works. We have stage discharge, and then we have, so we have the rating, and then we have discharge that is based on, ultimately there's a lookup using these two to create the discharge. What we will find in terms of approving things is if you approve the stage.logger, you can do that. Nothing else will need to be approved to do that. If you wanted to approve, so this is a high approval, the discharge.working, then what the system will do is for the period of this that you are approving, everything that was involved in the derivation chain for this will also be approved automatically. So does that make sense? So in a normal workflow, in the quarterly basis for NIWA, if we approve our discharge, it approves the rating and it will approve the stage records that we used it. So in our quarterly process, we should really only need to approve in one area, and it will automatically approve the other data sets for us. So that's something you need to get your head around in terms of approvals. So the point being, if this is approved, this is approved. If we then subsequently find that we want to edit this because we found an error later, we would have to drop the approval on this. Now, dropping the approval on this will mean it can be edited, but it will also drop the approval on this, because the basic rule is this must be at least as approved as its inputs. Or, sorry, the inputs must be as approved as it. So this cannot be approved and this be working. If this is working, this must be working. So when we go up, so when discharge is going up in approval, it will approve everything with it. And it works in the opposite when you're going down. If you need to take stage.working down, it will take the things that it is used to derive down. So taking stage.working down a state will also take the discharge down. So it's important to get your head and practice with these approvals because they do percolate through. Now, when we go through the examples now, the tool will tell you what it's doing. So as part of the process of trying to approve some data, we'll see, it'll tell you what other data sets, if you do this action here, what other data sets are also going to be approved because of that or unapproved. But the basic rule is as I described it. So if we come to the exercises. So what we're going to start with is the exercises, just looking through the data. So this is kind of mimicking, say, in a NIWA case, the quarterly update process. So basically, we're just going to have a review of the data, and then we're going to say, okay, we're happy with that. and let's approve it. So step one is saying, let's have a look at our stage.working. And let's just generally review the changes to see that we are happy with them. And so the process for doing that, again, in the notes, you will see they talk about the revisions section. It's now called the edit history. So where in the manual you've seen the word revisions, it's actually been relabeled to edit history. If you're looking at the manual, and we kind of go, well, in the picture here, there's lots of approvals. And yet in my default one, the list that I'm showing you, the list isn't quite as large. The thing to remember in all of this is when we are in the data review tool, the list of corrections we see is for the period of data we are looking at. So you can see, even though we've got data loaded for this long, we're only looking at this bit here that's blue. If we extend the period that we're seeing, we also see more corrections. So that is always something to keep in mind when using this view, that these tabs, these values and these other tabs over here are in the context of the data that you are looking at, not the whole record. So if we're looking to correct our data, generally we would just take a perusal round at the various corrections and decide if we're happy with them. And we would look at the sort of dates, where they apply, when we put them in. We can see when they were put in, if we use tags on them. Again, if they were automatically processing, what priority were they done under? So these are these things we started to do yesterday and we'd have a look at. Remember, we can also grab this tab and take it out of the display. So if you've got two screens, you might want to bring this across to your second screen so you can look at that and look at this table at the same time. We can sort them, we can drag them. So generally you would have a look around. You'll probably have some defined processes of people are looking at these corrections, making sure they're allowed corrections, because you and your business rules might say you're not allowed to use certain types. Like I could imagine that, where is it? Pencil type ones or whatever might not be allowed. So you can have a look and you can look at the corrections and decide if you're happy with them. Once you have decided you're happy with them, we look to correct the data, approve the data. So we've now decided that all the corrections are valid. Let's look to approve the data. So what we're going to do is we're going to work on changing the approval of our stage.working. There are two ways that you can change that, and we'll get to the user interface to change it. If you've got a data set selected, you can just click on this icon up here and it will open the approvals view, or under the data set itself from the hamburger, you can go change approval, and they'll both take you to the same place. What this is doing is bringing you to a view where you get to select what period of data I'm approving. So data is always approved in periods. Because we haven't got much data here and it's pretty historic, let's move it to a 10-year view and you can see some more information. So there are different ways. What we have to do in here is select the period of data that we want to approve. So we know we're approving stage.working. What period of data? You could click on this, which is based on the approval levels, and you'll see at the moment we've only got one approval level, so it's the same for the whole value. So that effectively selects the whole period. You could do it based on field visits. Now, for most of the stuff that NIWA does, the periods that we correct, part of our rule is, that we've done a field visit to confirm that the levels are what we've said they are. And so when we correct data in the quarterly process, it's generally to the last field visit. So for our people, they are likely to select a period based on field visits. Now there are a lot of field visits in there, but that's what these triangles are the indicators of the various field visits. And so there is a reasonably good chance that your process might be that you actually want to select, because some of it will already be approved, a period to your field visits, or ultimately, if neither of those views are giving you what you want, you can just manually choose the period, start and end time that you want to approve. So ultimately, you can always do it manually if you want to. So in this first example, they've said, let's just pick the whole 10 years and let's mark it to approved. Whoops, sorry, to approved. So the things to note. Remember I talked about certain ones above a value being a lock state? This is, you can see in the icons which of the approvals are a locking state. The one with a padlock on it are the locking state. So we know if we move to this, it'll be a locking state. The other thing that we talked about is that in the derivation chain, if we approve certain things, other things may be approved because of it, because of the rule, because they're derived from it. So if we look, we are approving stage.working, and it's saying, if you approve this, the ones with the tick, it says stage.telemetry is also going to be approved. Stage.logger is going to be approved, and stage.working, which is what we've asked for. So the items with the ticks are also going to be approved. So that's a good way to check. And so if you're surprised by this, you may need to look at what you're doing. If you are happy with that approval, what you do is you just hit save and the system will be approved. So you can see an icon saying it's progressing, and then it's going to give you a thing to say it's been successful. Yeah, it's approved. And now we see it's green, and we can see that the records have been updated. And to be clear, it does follow the rules based on dates and times. So if the period you're applying, if the thing that it is based on is not in that period, it doesn't get affected. So what's the difference now? If we look at our data set now, just remembering how we see this normally, if we go and look at the data review tool, we see on our carpets that it's all got the approved state. So that's what it's doing. And if we look just really quickly at say a NIWA example, if we looked, say, at our, so this is our NIWA system. If I look at our discharge.master, generally what you'll see is, so this is our quarterly process. Most of the history of the data is approved. We can see the quarter we're working on is currently being worked on by the team, so it's been approved by the team, and near real-time data is provisional. So very soon the team will be finished with it. They'll hand it to the database custodian of my team, and when she's happy, she'll approve this period. And you can see as our dates and times that we approve to tend to be tied to a field visit. So in our case, if they were approving, they'd be able to click on this to do it. So your carpets tend to start looking like this. You'll have periods of approved in history, possibly a period that's being worked on, and then probably the stuff that's still considered provisional. So this I would expect is quite a common looking carpet. I see we've got to 3 o'clock. Maybe do we want to take, before we do step 2, which is looking at approving a station, would we like to take a break for say 10 minutes? Give us everybody a chance to have a bit of a wander around before we carry on. Do we want to do that? Shall we do that? Shall I say it's what in my time? I'm guessing it's 10:04. Shall we come back at 10:15? See you all in 10 minutes. Oh, here we go. Sorry. Yes, is that okay?
Yes, sir, Michael. Can we do a 10-minute break?
Yep. So shall we say back at 10:15?
Certainly, sir.
Okay. See you all in 10 minutes and we'll carry on.
Ma'am, hello. Hello, ma'am.
Sir Raha, dito?
Ma'am, maghapon daw po ba ngayon?
Ay, sorry po, ma'am.
Maghapon daw po ba tayo ngayon, ma'am?
Ay, okay. So, as scheduled po, hanggang 12 lang po tayo. 12 lang, sir.
Graduation natin mamaya, ma'am.
Yes po. If ever po, I can ask siguro Engineer Michael if we'll be able to finish this one up until 12. So Engineer Michael, will we be able to cover all the topics up until 12 noon? I mean Philippine time.
Yes, well, I think we probably have about an hour's worth left of the lessons in the course, probably about another hour, about that. So we will be finished early, I would expect. Is that
Oh.
is that what you would do you want? If I finish early, have you got other things you would like to do?
None, sir. I would just like to confirm because we also will also be having a closing program. So we do have to contact the person who will be delivering the closing remarks to. So we're just confirming if it'll end by 12 noon or we'll have to extend later on.
Yeah, my expectation is, but the way we're tracking, we will be early. Yes, I think probably about another hour.
Okay. That's good. Okay, thank you. So shall we continue with the lessons?
Sure.
Okay. Participants, please settle down po ulit and then we'll continue now with the discussion of the remaining lessons for this webinar. Thank you.
Can you see my screen again?
Yep. All good.
Okay, so what we did in the previous exercise was a sort of review of the stage record, and then we decided it was all right and we approved it. So now what we're moving on to is sort of saying, well, we also had a rating during that period. Let's do a bit of a review of the rating. And then if we're happy with that, let's approve that one as well. So exercise or step 2 on page 121 is, I guess, working through the sorts of things that you might consider in checking your rating. And then we'll go into some approval on it. Oh, you don't need to see New Zealand news. So in checking the rating, the sort of thing you would want to do is I guess look at the ratings that are in the period you're considering reviewing. So you would probably have the ones in the order of particular interest. Once you've created a rating, is the deviations of the rating from the curve. So in New Zealand, our rule in terms of when it's time to start looking at a new rating is when our gaugings are plotting more than 8% off the rating, then we are generally starting to look at, well, is it time for a new rating? That's kind of the error margin that we have. If that rating is due to if that gauging, that 8% is due to a change in conditions. So having a look at the error of the ratings, you can do it by looking at these tables here or on an individual gauging basis, as we did yesterday. If you click on the gauging and look at it in these other views, you can see the errors. So this one is basically saying it's 4.16% off the rating. So that's within 8%. So we're sort of saying those are okay. But so as part of the review of your rating, you're likely to look at the error percentages of the gaugings relative to the rating, because that'll give you some idea of how, how good is the fit. Another area that the hydrologist will tell you, and again, it's not the area that I'm expert in, is we did talk about it yesterday though, was based on understanding your site and the geometry at your site. You will have some understanding of what kind of exponents are likely to be in, you should expect in your rating lines. And so one of the things to check in terms of the rating that you've prepared and reviewing it is, are those are the exponents making sense for what you know in the real world of the site, and does the offset make sense in terms of your understanding of the site? So that's something you can also check, evidence that this is now a good rating. If you're using grades, you probably want to review the grades you've assigned, again, to think about whether they make sense before you look to approve it. So you would go through and just check your grades. One thing that you want to get correct is the dates that you say this rating applies from. So you should probably just check that those dates are correct in terms of when they start, when they stop. Are they overlapping? Is there an overlap? And if there is an overlap with them, is the overlap period sensible? And then if you're in the USGS method, you might have some shifts, and so you would review them to see if they were appropriate in the way you've described the change. Assuming all of those things are correct, you would go, good, look, we're happy that this is a good solid rating, let's approve it. So now what we're going to do is we're going to go and approve the rating. So the process for approving the rating is pretty much identical to that we did for the stage. And so we have two choices. We can either click from here, change approval, or again, tick it, and then go to the approval screen. And we get a similar sort of view with a time series, with a timeline that's based on approval levels, so other approval levels. Again, because we haven't approved anything else, we've only got the one in this case. We can prove it based on field visits, or again, pick our time if that's what we want to do. In this suggestion, I think they suggested what we do is we approve up to the end of the field visits. Now, if you're following along, if you watch what I do here, I clicked there and then I click here, and I've managed to select all of the period between those field visits. That's similar to our other selection process. At the first one, go to your end, hold the shift button down, and then click with your mouse. Will allow you to select, effectively begin and end and all the bits in between. Otherwise, you can just pick the ones you want. So it could just be that period that you wanted to approve. Maybe it's those couple. Normally, you're not on a 10-year scale when you're doing this, so those field visits won't appear quite as close as they do in this view. Normally you're talking about the last few months, and so field visits are a bit separated out and easier to identify. Anyway, they have said let's select that period, and what approval are they telling us to do it? They've said in this case in review. Now this is where in the notes they've said make it in review, and we can see what that's telling us is by this approval, the only data set that's being impacted is the discharge, is the rating curve. And if we think about when we go back to this diagram, does that make sense to us? There's nothing that's used as part of the derivation of the rating, so that's fine. Nothing down here is impacted. Why? But we know the rating is used to calculate the discharge. Why was the discharge not approved? And the reason is it's okay for something this side of the chain to be more approved than the discharge. So the rating can be more approved than the discharge, but it can't be less. So because we're improving the approval, we're increasing the approval here, that's okay. It doesn't necessarily have to do that here. So in actual fact, that does make sense that it doesn't approve anything else. So if we then look at this, so we've done that, let's get out of here. What does our discharge look like now in terms of approvals? So let's have a look at our discharge dot working. So as we noticed, it hasn't changed. So nothing we've done yet, because we didn't approve the working, the ones underneath it can be approved further up the chain, but that doesn't force the discharge to be approved yet. If we want to do that, we need to approve it. What we do notice about the approval we did on the ratings, we can see that in the rating editor. So if we go back and open our rating in the rating editor, we can see the approvals in this rating period manager. So this bit over here where you set the dates, you can see the approvals. So we can see this rating, and because a rating can have multiple approvals on it, because some of the rating period might be approved and some of it might be provisional. When we look in this view, you see the list of approvals that apply for this rating. And so we can see that some of this rating is working and some of it's in review. And we obviously just increased it to in review. So now let's do the last step, which would be the discharge. So effectively, we've said the stage is okay, the discharge is okay, the rating is okay, so there's no reason not to approve the discharge. So let's do that. So we go to the discharge, we go to the approval tool. We're wanting to take the whole period for the sake of example, and we're going to make it all approved. It's telling us that if we do this, it's going to approve the discharge, which of course is what we expect because that's what we want. But it's also going to increase the approval of the rating. Now that's because what we did before with the rating is we took the rating to in review. So we took this to in review, but now we're going to try and take the discharge to approved. And because that is higher than in review, if we say yes to approving this, this must be approved. So it's going to pull this one up to approved as well. This one doesn't need to change because we've already approved that. That's what we did in the first lesson. So that one doesn't need to change because it is already approved. But this one is currently only working in review, sorry. So it's going to be approved by this action. And that's what this view is telling us. So in actual fact, when we think that through, again, that is what we expect. So let's go through and approve it. There we go. So it's approved those things. The implication of this is now for these items, if we go to stage.working and pick a period of data, say we decide that we want to delete a period of data. So let's just pick a period. And see what it's saying here? Selection intersects locked data. Only location note is available. It is saying we cannot edit the data. Now, we talked about that. Locking states mean nobody can edit the data. So once we've locked it, we can't edit anymore. We can add a note because that's not considered an edit, but we cannot change the data. So how do we get around that? What we have to do is we actually have to take the approval down on the thing we need to change out of approved. So to do that, for example, we would go to here. Let's pick a period. So let's say pick it all. because it's the simplest thing to do, and take it back to working. Now, if we look at what that's telling us, it's saying this is the one we chose to do. It's also going to take the discharge.working. So in this diagram, if we look at this, I'm trying to take this back to an approval where I can work on it. And it's saying, if you're going to take this from approved to working, I'm also going to take your discharge down to working. Because this must always be at least as approved, cannot be more approved. So if we take this down, we have to take this down. But it's going to do it automatically for us, but you just need to note that it will do that. So if we follow that through, we take it back to working. It's made that change. If we now go back into our stage.working and try and do an edit, it's going to let us do the edits again. Now, the trick to remember with that, because this is what our field teams need to remember, is commonly what might happen is we've approved everything. A person works out, more commonly our stage doesn't tend to get edited much after our quarterly process, but on occasion we might find that our rating was wrong and needs to be edited. So we would move this down to the working state and then we'd work on it. And the temptation would be for the team to then get this rating reapproved. The trick you've got to watch is if you take this one down from approved to working, that will also take the discharge to working. If you then subsequently take the rating when you've finished it back up to approved, it will take that back up to approved, but it won't pull your discharge back up automatically because it doesn't need to. It's okay. This could be more approved than that. That's okay. So you've got to actually, people need to understand that in that logic, if everything's approved and you work on the rating, you would bring the approval down on the rating to work on it. But when you're finished, you should really do your reapproval back up on, you need to do the approval again, back up at the discharge level. Otherwise, you'll end up with a discharge staying at the working level, even though you've finished with it. So it is quite important that you understand how these approvals work when you start using them, because of that kind of scenario that there are efficiencies to be made and things just to check. That's probably enough as an introduction to approvals. I mean, they work consistently, but it's important you get your head around them because they're not, I guess it's the sort of thing that I find you do need to think them through. They're not intuitive in terms of, for a while, if I approve this, it's going to unapprove that, or it's going to approve these other things. And if I unapprove it, it's going to unapprove those things. And therefore, when I reapprove, I have to approve over here, not down here. They are all sensible and they all make sense, but you do need to just get familiar with them as part of the tool and get your procedures right. Generally for us, the teams, it's pretty simple in the end. Our teams do, the general guidance is you always do your approvals on our discharge. The approval changes on the discharge, and that tends to approve everything else. The only time we don't is if for some reason we are happy with the stage but not the rating, then we obviously can't do that. But if we know we're happy after review with both of those, then we just do the approval at the discharge level. So it can come down to some quite simple procedures. I'll just put that note up there that AI have noted about, I guess, the general trend towards approvals and things. And just let you have a read of that. And does anybody have some initial questions about approvals? Otherwise, we'll move on. Okay. Our last topic that we're working through is going to be looking at just some of the capabilities to export this data and looking at the process of running reports. We're certainly not going to run them all, but you're going to see how to run them. So what you can do is stage one is you can define your system to put a header for your organization in the config of reports. And I have organized this so that you can do it. So if we look at the moment, if we look at your use, there is no organizational icon here or in your reports. Now, if we get this right, we will get an organizational icon for NIA appearing here. Now, I just need to remember what we called it. Because this image, what we have done is you have to load the image onto the server, and then you can set it up to use it. So I've organized for your image to be preloaded onto this test server, and then we're going to add the reference to it. Just need to remember the name of it. Okay, so if we work through the example, now realistically only one of us wants to do this because this is a system-wide setting. This is not set up per user, so maybe I'll just do it. So we do this through the system config. So this is, as we now know, is through the system config. We can go to the options. This one is sitting in your settings. So in this part of the tool, and we're looking for icon. And what we put in here is the name of the icon, which I just checked should be NIA space logo.jpg. So once we've done that, hopefully if I've done that right, and we come back to here and refresh, we now get an icon in here. So there is some configuration ability that you can use, and these tend to get substituted into some of the reports and things like that as well. So if you start working through the system, there are some basic settings you can do to sort of customize the look and feel a little bit of your system, as well as how the reports come out. And clearly that may not be the icon that you choose to use, but that was the one that was supplied to me to help demonstrate that. So just looking through that. So this was the example, and we've done that to show that it's turning up. You can also see here that we're also saying you can do page header and page footer key values as desired to put your company name, example disclaimers. So if we look at these sort of settings, again, we're talking about in the settings section, they were suggesting we were searching on page, say, if we type in page, we should see. So we can put page headers and footers, and we can put text in that you want to go into those. So they have default values, but you can customize them to suit your organization. So having done that, what we're saying is these things will now appear in the report. So maybe what we'll do is, for the sake of it, we'll just add the words NIA. Whoop, yeah, NIA. just to show you that hopefully it turns up, and we'll add it. Just to demonstrate and prove that it's turning up. That's probably enough to I did put that in the right place, didn't I? I did put it in the value, yes. So when we generate a report, we'll have a look and see if we see signs of those turning up. So now we'll move on to actually trying to generate a report. And the first one we're going to do is a change list report. So all those corrections that we've done, we're going to do a report that gives us some form of output of those in a reporting format. So to do that, we go back to our base Springboard view and we bring up the reporting page. And then we peruse the list of reports that we want. And in this case, we're going to do the change list report. This is a pretty standard pattern for the reports, which is about what period of data do you want it for. Often there is some form of options. So some of them will have sort of CSV type outputs as opposed to PDF. You have an option for whether to keep the report permanently on the system or not. Part of that is also if you move on to using web portal, that also ties through to that reports that are kept permanently can be linked through to web portal. So you can end up bringing some of these reports through and making them available through web portal if you get to that stage. For now, we don't need to do those things, but they have said we should set the date range. So we, as per normal, there's some common answers where ultimately you can put in a date range. They've said, let's do 2013, 1st of August. And then put today's date for the end date in. Time series that we want to use is stage.working. But we've got to do the location. So Arid River Mike. Stage.working. You can give the report. And we can, if you got things, you can filter potentially on tags, but we don't need to on this one. And so then what you do, well, they've given us a description, so let's put it in. And then we run the report. So the reports then run in the background. So you see you get a note saying this is happening and you'll be notified. You get another notification when the report is finished. To find the report, you go up to this top tab in the view, and you can see that there's one report there that's been added. So we go to generate reports and we can have a look. And then you can click on the report to have a look at it. And there we can see immediately that we've got your icon. The footer has the little NIA bit that we added to it. There's the header. So those things come through. And then the report itself is a list of the corrections for the period that we did. So basic summary, similar to what we saw in that overview panel. We could try another report. Oops. Let's see if we can just produce another one. You can do a rating curve report. So this is the sort of thing, someone asked me the other day whether rating curves can actually go through to web portal. So while I said no, but you can possibly work around it, this is sort of what I was thinking about, that there are these reports in the system, and if you get advanced, you can actually, through the API, build your own reports and put them into the system. And they can be fed through, reports can be fed through to web portal and made available. So in that way, ultimately, you could make a rating available through web portal, but it would be through that kind of process. Create a report, put the report through the web portal. So that's where the sort of supportive ratings would be in terms of coming through the web portal at this stage, through reports if you chose to do it. So let's just try this. So let's try Aaron Rimmer, Mike. Check our format. So that one again only has one option. Increment. Let's do it for the whole record. So measurement eyes, okay. So measurement statistics, let's go with it. Let's run that report. So again, it's running, it's letting us know. And then it generates the report. So we see it in the list. Where's the rating report? Let's have a look at what it looks like. No rating model found with parameter stage discharge and rating label rating curve, right? So we didn't configure that correctly. So let's go back and do that again. So the rating model. So if we look at, I think it's log method is our label. So where it asked for the rating model label, we needed to put log method in. Hopefully this will run with a bit more content in it. It's obviously having a bigger think about it, so that tends to suggest it's doing something. Yeah, it's finished. Let's have a look at it. So that one, that wasn't too good. Which one did we do first? That one, let's just delete that because it didn't have anything useful. So we can get a report out that shows the rating curve and the effective rating table. So you can see there's all these sort of standard output reports that can be produced. And they're all a very similar process in terms of running them. So I don't know if you have any sort of standard reports, but some of these daily statistics by year tend to be fairly standard types of reports that people want to output. Double mass plots are quite useful as a QA activity. They basically plot volume of water for two sites against each other, and the expectation is that they tend to operate in a straight line, and if they deviate, if the pattern sort of changes, you see a change in the relationship between the two sites, which is a sign something's changed and may need checking. There's all sorts of reports here that you could look at and choose to use. Time series data is probably the most configurable, I guess. This is the one where you can of a direct calculation in. So you add a process to it. So you say that process is, say, a count and intensity analysis. So you could use this to find, so say from a rain record, the highest 15-minute value in a period, in the month, or the highest day in the month or something like that. So you can do, I mean, this is a stage record, but you can do a statistic. So we could do the monthly mean, say. So let's have a go. So let's do a monthly mean every month. Let's make it the whole record so we go through. So monthly means, oops, not that I can spell. So what we're saying here is we're picking up the stage.logger. We're doing a statistic, which is the mean. The mean is a monthly mean. We're doing this again, beginning of day. We could put the coverage in. So it's a very similar sort of pattern to actually setting the statistic up as a time series. But if you haven't created it as a time series, you could just get it out as a report value. You could chain processes together. So you can add a subsequent process. So the output of the first process becomes an input into the second one. So you can chain processes together. So you could potentially get the events out where the number of events where you had the rain rate for an hour was greater than 50 mil, and then you could pass that through to a process which was a count, and so the output would actually be the count of those in the month rather than just the events themselves. You could just get out the count. So that's how you might want to put them together. I'll delete that one. You can also add other time series to it. So this is essentially, this report will be a 1 column report with 1 mean value. If we added another time series, that would effectively be per month in the report. You'd have 2 columns. You'd have the first column, which is the mean for this site. And then if say we put in a different site, you would get the mean for the second one. So it would become 2 columns. So you can put together and configure up a report to suit your needs. So let's just run that and show you the sort of output. Oh, and this one I obviously selected a CSV. So we can see that the output, there's your month, and that would be the mean for stage it thing, and it's telling you it's a monthly means. And we could have got that out, I'm guessing, if we went back and had a look at that. We could have asked for that as a PDF or a plot to a PDF, various versions. So there are different output formats for some of the reports depending on what you're doing. Some of the hints, if you get into being programming, the settings that are used by this report are available to you. So there is an ability to schedule reports within the system. If you look at sort of the advanced capabilities, a report, because this is designed for ad hoc, but what you can do is you can take these settings and run it through a program to do the same thing, and you can obviously schedule that program to run. So under the hood, there is an ability that you could, using, I think it's called Report Runner, using a Report Runner and grabbing configurations of reports, schedule them and make them routinely generated. So I do, for one of the clients we've got, I've got a series of monthly reports that we generate every month and then flick through. And in our case, we publish them through the web portal because that's what the client's using. So that can be done. The one thing that's a bit of a trick that we didn't pick up for a while, and I did sort of show you this the other day, but not entirely, is in the system configuration. The reports that you see are defined by what's listed here. So there are some reports that aren't enabled by default. And so, well, that one is, but some of them aren't. So if you want to be able to use them, you just have to, assuming your admin, is enable them. And then when you come into here, so what was that one I just enabled? Locations data, I think it was. If we came back to this view again, we should expect to see that there is now a locations data report available to us. And if we do entire record, does it look like we have to configure report title, spreadsheet? Let's do it as a PDF. So what does this one do? I think this one lists your locations basically, which is actually quite a useful thing to have as a report, I think. So let's have a look. What did that one do? So it basically gave you a list of the locations, and you could, and because I didn't filter it in any way, it's basically a dump of all locations. So you can see all the ones that have been created by people, the training ones, and so that's a location, which is quite a useful thing to be able to do, but it isn't actually enabled by default in the tool. It is now in that sample one. So just, I guess the advice is when you start using your system, you would want to go through these. The documentation of what some of them do is not always great. So some of them, many of them, you just have to try them to see what they do. I mean, their name hopefully gives you some idea, but often you have to really experiment with them to see. And some of these have probably been built fairly specifically for clients. The standard way aquatics work is they don't really like, this is a standard product that everybody gets. So if someone asks for a report specifically for them, the pattern is it will get added in. Predominantly, I mean, unless it's very special and available to everybody, but I guess it might just be turned off by default, so that it doesn't get in the way of people that don't really want it, because it could be quite specialized, I'm guessing. So some of these probably wouldn't make much sense to you, and that's because they've been built for a specific client, and not really intended for everybody to use, but because it's a single product, they put them all in the same environment. That's probably enough. Are there any questions there about how to run or these reports? Because otherwise, if not, we'll move on to just having a quick look at how to export data. But any questions about the report mechanisms while we're looking at it? You can do flow duration curves, event analysis, intensity analysis. Those are probably some of the more common ones. You can do a windrows. So if you bring in wind data, you can do a windrows. I am doing that for one of our clients. We are using that. No questions? Okay. So if we move on to this one, we're going to export some data. And we're just going to export it to CSV. So this is basically taking a simple time series and exporting it out of the system. And that's pretty straightforward. So we start from our springboard, the location, what example they wanted us. Discharge daily mean, they've suggested we export. So this is one of our derived data sets. To export, it's this icon here. So we click on that. So having selected the data set, click on the export icon, and we get some options for what we set. We can set, let's keep it simple and set the entire record. We can choose to export the corrected data or the raw data. Now, hopefully people have now got that concept. When a time series comes in, the data is first loaded. That's its raw data. Any corrections that are applied on that are then applied, and then you end up with the corrected data, which is once all the corrections have been applied. So you can ask to export the raw data, i.e. what was first loaded, or you can say what is the view that, the best view that we have now. In general, and by default, you're going to export the corrected data, but just be aware you can export the raw data if you choose to. You get the option to say whether to include gap markers or not. And if we then export it, it downloads it to your machine as a CSV. And it will include items. If we look at this, it includes the date in the ISO format, which is great, except for Excel doesn't understand it. It's the format generally as a programmer. So for a lot of the stuff I choose to do, that is a great format because it is entirely clear what time zone you're dealing with. But it also outputs it to you in the local time of the location, which in this case, in our example, was UTC. Then the value, what its approval was, and what its grade was. And if there were any qualifiers on it, it also exports the qualifiers, and then you've got that data. Okay, so that's an export. If we look at step 4, is we're back to a report. So it's going to be a daily statistic by year report. So these are, again, one of these common ones I talked about. So let's go back to that. So we're going to do this back to our reports. Daily statistic by year. So you can do last complete. They have said we want to put in a date range. Again, this 2013, 08, 01. Today's date, presumably for the end. Put our location in. And discharge not working. And so then the bit that we get to set is what's the statistic that we want to do per day. So let's stick with mean, and we're going to say that there's a coverage. So to calculate that statistic, there needs to be 80% coverage on the day. And put in a report title. And then we run the report. And if we look at that one, so what that is not surprisingly per day in this kind of calendar table format, what the daily mean was. And if there wasn't 80% coverage of the day, then you get this asterisk, asterisk, asterisk. And you'll see that it goes through the record and does that for every day. So that's, I think, I mean, that's my experience. That's a relatively common report that people like to see and monitor. So the next step we're going to do is have a look at an event one. So we're going to look for events over a certain size for a certain period of time. So let's have a look at this because this is a good hydrological one. So event analysis, same date. To today. Add the input. And we're doing it on the stage.working. So we're going to do events above 4 meters because we're in metric. Minimum separation is 30 minutes. And minimum duration is 2 hours. So what that is, that configuration, what that is saying is we are looking to list events that are above 4 meters for at least 2 hours. And the record must go below 4 meters for at least 30 minutes before it is considered a new event. So if the record goes below 4 meters, but then back above 4 meters within 30 minutes, then that's still part of this first event. That's the separation is how long does it need to be below your threshold before you consider them two different events. And let's run that one. So what this should be is it's a list of events. So it's the begin and end time for the event, what the maximum value was and how long it was. So you can see how long, so this one, there was 66 hours of it being above 4 meters. And it got as high as 9. So I think that's probably, I think in that record, that was probably the highest event we had in that example data. So it was also the longest. So that's that kind of report. And then if we look at those areas, really what we're talking about is just a quick summary of what some of these other reports do. So that's in your notes to have a look at. Flow duration curves, a lot of our teams here do, we use the flow duration curves for some of our science, so that being able to produce a flow duration curve is quite useful. Inventory, if you start putting in your kit and things, listing it, you can do that. I think profile plots are probably, by the look of them, they're probably designed if you have, say you've got a temperature chain or something like that in a lake, and you've got a range of them, then I think presumably profile plots are probably to help you plot that sort of thing, perhaps. Gradient curve scatter plots, so they're quite useful if you're doing water quality type data. This time series one, that's the one I talked about that's quite flexible. USGS, that's a pretty hard-coded one for them. I don't think I've ever used it. And then windrows is this. If you're doing wind information, that's useful to be able to sort of plot up a windrows for the data. So there's quite a lot in there that are worth looking at. It's also worth remembering that those ones that I said that aren't enabled by default, every release, well, not necessarily every release, but there are often extra reports added as part of the releases. And so that's one thing for being on the service agreement, is you get those each time a new release comes out. So it's quite valuable to stay on top of those for that purposes. And ultimately, you can start writing your own once we start talking about APIs. So that is, I think, where have I gone? That brings us to the end of the material for the exercises. So are there any last questions on any of that? If you want me to continue, if there's no specific questions, there are a couple of things I have noted I could talk a little bit more about in terms of just probably re-reviewing security, a little bit on the APIs and some of those resources, if you'd like me to quickly go on that, or do you want to just go into your end of session wrap? Would you like me to, in terms of getting ready for your end of session wrap, when would you like to start that? I can do a little bit, do you need another 10 minutes, or how are you going with your scheduling?
Again, sorry.
I'm just saying I've got a couple of other things that what we have done is we've finished the material that's in it. I did make some notes of a couple of other things that I could just spend a little bit of time going over. If you want me to, or do you want to, have you set a schedule up for your end of session wrap up yet? Do you want me to, are you set that up for a time? Do you want, have I got 10 minutes, 20 minutes? You want to start straight into your wrap? What would you like to do?
I think the participants will be glad to know those other informations as well. So it's okay. We can still discuss that since it's just 11:08 here in the Philippines.
Okay. All right. So what I thought I'd do, they weren't strictly topics, and I've touched on them a little bit, but I thought maybe just these topics would be worth just, again, not getting deeply into, but just revisiting now that we've used the tool a little bit. So the first one was just really just going to have a quick revisit of the security aspects of the system. So if we look at that, if we look at users, all users are defined. We can see where users are defined by going to our system configuration. and we can see the list of users. And there's different ways that users may be getting their credentials, presenting credentials, Active Directory, user credentials there, which is basically a straight Aquarius username and log on, or OpenID Connect. All of our examples in this training sit here. So for each user that is listed here, we can see the login, and then the main things that are controlled here are whether they're active or not. So you can keep a user defined but make them inactive for a period of time. We control whether they can see the rating development toolbox. So generally when you buy Aquarius, the licensing, you may have more users than you have licenses for the rating toolbox. So it's this tick that needs to be given to the users who need to do the rating bit that we saw. So often, you know, you might buy a system that's got 30 or 40 users, but only 5 of them are actually going to use the rating tool. Those 5 need to get that ticked. And then again, an overall setting of whether the person can configure the system or not. The rest of the configuration in terms of what a user can do is controlled by their role and where that role is given to them in the context of the folder structure. So what I mean by that is, if we look at this, to see what roles everybody has, ours was quite simple. We went to the Springboard. Let me do that again. From the Springboard, we went to have a look at user access. And what we can see is we don't have much of a folder hierarchy defined in this implementation at the moment. And we can see that everyone has been given the admin role. Now, in production, clearly you're not going to do that. It was useful for training, but isn't what's likely to be done in production. But we can see the role that people have been given. And some people may have only been given a role to some parts of the hierarchy. So the role, by looking at the locations, that effectively says what locations can I see, because locations are put in a folder. So by potentially giving someone, if you give someone a role at the top, then they can see all locations. If you put them in the hierarchy, then they may only have access to some of the locations. So they may not be able to see them. The other aspect of, well, okay, that defines what I can see. What defines what I can do? And that's defined by the role. So the best way to probably look at that is for me to switch to the NIWA view of how we've done things. And if we look at it, because it's a more complete example to demonstrate what we're talking about. If I go to the NIWA one, and I need to log in as admin to do this. Is if we go over here and specifically look at me, say, if we look at our names, my name is Barge MJ. So we find me in the NIWA list. You can see I have the role public, but it's on all locations. So I can see all locations, but I only have the role public. And in the case of NIWA, let's see what that means. So having the public role, if I go to the system config and look at the roles and find the one that's called public, you can see under my normal login, the only thing I can do is read data. Because most of what I do in my role at NIWA is about checking and looking at data and things. I'm not a person that actually goes through and corrects and does the field work and things like that. So I've only got read data. I can't modify any of the data in the system. Whereas admin can do everything. The other thing to note about the roles is we've seen these examples where all these numbers are involved and they say 700, 800. What does that mean? What that means is these numbers, well, in actual fact, we need to probably go back to in doing this bit, let's go back to the test system. if we look at the test systems admin role, you can see that there is this magic set of numbers, and you're kind of going, what does that mean? It actually ties to the approvals. If you look at the approvals, see how the approvals are 800, 900, and 1200? And what this is saying, this line here says the admin user is allowed to make approvals that take data from approval 800 to approval 900. They can also take they are also allowed to take approvals from 800 to 1200, 900, 800. In this case for admin, we've put all the combinations in. So basically, the admin user is able to do all the transitions of approvals. They can take everything from one to the other. But what it does mean is you can have certain roles that can't do those things. In the case of NIWA, we only have our admin person, Kathy, who's our database custodian, is the only person that has the role that allows her to approve data. Everybody else can do some of the other transitions. They can take data from approved and downgrade it, but they can't actually do the approval. There's only the one person with that role that is able to do that. And that's configured, that sort of setup is configured by these parts in your roles. That's what these numbers are saying, what can you do? So that's an important part. So that's probably just a slightly quicker look at roles and how they work. We already just today had a quick talk about programming interfaces. So this is, depending on how advanced you become in the system as an organization, you are likely to have people that want to use the APIs. So at NIWA, all our scientists tend to access the data out of Aquarius by using these APIs. For the scientists, the most commonly used programming interface is the publish interface. So this is really for computer programmers. But the thing in learning about that is if you click on that as a user, you get taken to a thing that's called, taken to an interface to use it. So you can practice using this system before you write the code, and you can see what calling this stuff is likely to return. So, sorry, I should just do that a bit more slowly. When you open the API, it takes you to this base page, which is quite a lot of documentation on how to use the various calls that are available. And if you actually want to do a practice call of one of them, you move to this, what's called the Swagger API. And that lists all the functions that are available through this API. And you can test them. So not surprisingly, this one here will get the list of locations. So if you click on it, it expands up and you can practice on it. Now you can put in a location identifier. So we could put, what was my one? Training 16, I think that was me, and try it out. And you can see what it would return. So, and this, for those that don't know, this is called a JSON response. So this is what making this call will return. So while for many of you who aren't going to work with programming interfaces, this looks a bit like gobbledygook, anybody that may use this for computer programming, this Swagger interface is a good place to start because you can practice and you can see what responses you're going to get in your code, and that just helps you develop your code. So in this case, it just returns the one site. If we changed it and took out the name and just left it open and ran it, oh no, it's going to forces us to have to in this one. But if we get location description list, I think this one, if we just click on it, we can just, it'll give us the entire list. So this one here, you can see it's bringing back all the locations, some basic details about all the locations. So the key point here is that if any of your team are going to start using these program interfaces, coming to the Swagger is a good way to practice and see what they do, work out what configuration options are available, how to set that up. So it's very valuable. So if any of your team do that, just point them towards this side of things. The other aspect of that is that Aquatic Informatics have provided quite a lot of utilities to extend the system that typically a lot of them work with these APIs that I was just talking about, but they're available as software that you can just download. So if we use this link is quite valuable, and if you go to it, there's this landing page which you can work your way through, but getting started is a good one. And you can see some of these utilities that are available. Now, if you remember back, I said you can build your own custom utilities for teaching the system to import your field data in your format into Aquarius. These are some of the tools that can either do it for you or help you do it. So working your way through these. So this tabular CSV plugin is probably the way, if you want to do your own field visit loading, is almost certainly the method you'd want to look at. And that's available as a utility to help you do it. So there's lots of little utilities. If you want to automatically get the system loading attachments in to the system, then there's a utility to help you do that. Diagnostically, if your team who are supporting these servers ever have problems with them, almost certainly the first thing the aquatic support people are going to ask you to do is run system sizer on the system. So that utility sits here as well. So that's a very important resource. It's also, if you're going to work with the API, there is lots of example code here to help you do it. So if you're a .NET developer, there is example code. There's a whole software development kit to help you do it. If you work other common languages, there's some examples in Python using R. So some of the common languages. So there's lots of, if you use Tableau, I think this is a connector for your analytics. So there's lots of little connectors and things. Lots of utilities in here that can be very, very helpful. So keep track of that, that URL. This GitHub Aquatic Informatics. There are a lot of resources there as you look to advance your capabilities in using the tool. Probably not where you're going to start, but as you mature in your use of this product, you might find a lot of those very useful. That's, again, unless someone has some questions about that, that's probably enough on those topics. So I'm happy to answer any questions. Otherwise, thank you very much for listening to this over the last 4 days. And I guess one last reminder, just while I'm at it, is if you remember in these utilities, for those that didn't pick it up, in the material that you've got, all of these videos are already available. Not the ones of me. I see someone has been recording these as well, but the aquatic informatics versions of these exercises are all recorded, and you've got copies of those. So if you want to go back through those, do these exercises again, the test system is available for you to try that on, and there's videos to help you replay that again if you want to do it. Okay, I think I've said enough. So you've got seismic sensors. If the output is basically a time series and a timestamp and values, I mean, if the output of those things is numeric, then I think the answer is generally yes, without knowing any better. So you would probably be looking at potentially adding your own parameters and units for those into your system, and then putting in an ability to load them in. But I think the answer is without knowing exact details, yes, probably, as long as it's numeric. the system, if the frequency of the data gets too high, if you're talking many hertz data, then probably you need to look very carefully at high frequency data just because of the amount of data points it generates. But certainly if you're talking sort of minute data onwards and it's numeric, then almost certainly.
Okay, any other questions, participants? So, for participants, please do take this time to ask every questions that you have so that our speaker will be able to accommodate them. So, if you do have any questions, please don't hesitate to ask our speaker. You can type them in our chat box, or you can unmute your microphone. Okay, no more questions. May I request everyone? Okay, sorry.
In the chat box.
Yes, that has been answered by our resource speaker. So he said that technically, yes, we can use or we can integrate that one about the seismic sensors in the time series and publish it sa web portal. Any other questions po? Going once, twice, no more? Okay. So if you do have, if you,
Excuse me, I have a question.
okay, go.
I can see that in the exporting of file, I didn't see some Excel file options aside from CSV or PDF. Can we export this as Excel file?
Engineer, I'm sorry, but you're on mute.
Sorry, the CSV types generally will load into Excel. So anything that's a CSV one would load in Excel. So that's how they standardly do it. Some of the web portaling exports more tend to have an explicit Excel option, but I think in the Aquarius stuff, yeah, they limit it to CSV, which should make it load into Excel.
Okay, so Engineer Michael mentioned that yes, it's possible. So it's CSV is a supported file which you can also load in Microsoft Excel. So any other questions? Three, two, one. Okay, if you do not have any questions, may I request all participants to please turn on your camera so that we can take a group photo for this webinar. So let's open our cameras. So, Engineer Michael, is it possible to unshare your screen so that we can
Oh,
see the
sure.
video?
Sorry. Yep, there we go.
Okay. So please turn on your cameras and then we'll take your photos. Okay. Okay, so I'll be taking group photos in 3, 2, 1. Another shot. Okay. For a while. Let's take a group photo in 3, 2, 1. Okay, so now that we're done with the discussion of our lessons, we'd like to thank our resource speaker, Engineer Michael Park, for all the information he shared to us, which will be beneficial in doing our duties and responsibilities in our respective divisions. So now we'll be proceeding to the post-test and post-evaluation of this webinar. I will be sending the links. Okay. Sorry. So our participants are requesting to take your photos without mask. So will it be possible to remove your mask? Para may remembrance kayo. Okay. In 3, 2, 1. One more time. Sorry. Okay.
Oo, Sinta. Oo, po.
Okay, one more time. In 3, 2, 1. Okay, thank you.
Sige,
So
tanong ko
now-
ha. October 30 punta ako mamaya.
So now,
pero
Engineer
na-acknowledge
Michael
naman
will
nila
be just
yung email
having
mo.
a post
sige.
test. So I'll be giving the
Okay,
participants
baka may check-in na
link
yun.
for their
Okay,
web test and then overall
oo.
evaluation. So
Okay.
please allow us for at least 10 to 15 minutes so just they can answer the questions. Will that be okay with you?
That's fine.
Okay.
Yep, I'll be here.
Okay, so participants, I'll be sending the links for your post-evaluation exam and this one. Okay, so here's the link for the post-test and sending you here the link for the overall evaluation.
Bakit ikaw hindi nagtanggal ng face mask?
Ay, sorry po, nasa isang room kami. Na-COVID na po ako, so takot na po ako. Baka po hindi niyo ako makita ng isang buwan kapag nakapag round 2 pa ako ng COVID.
Talaga ba?
Oo, sir. Kakabalik ko lang. So again, we're giving you up until 11:38 to answer the post test and overall evaluation of this webinar. Please do answer the post test and evaluation because this will form part of your requirements for this webinar. So if you will not be able to answer this, there might be a chance that you will not be given a certificate. Thank you.
Parang maganda kasi yung host, ano?
Last 5 minutes.